Coming to the second component of the instrument, that is filters and monochromators. These filters and monochromators are most important design feature of the instrument, because when we are passing a radiation through the sample, we can get polychromatic or heterochromatic light of several wavelengths from the radiation. So these polychromatic light can be converted to monochromatic light by these filters and monochromators. So when we are passing the radiation from the sample, we can get polychromatic light or heterochromatic light of several wavelengths, but we need only a single wavelength or monochromatic light. So for that purpose, we are using these filters and monochromators for converting this polychromatic light to monochromatic light. So first, coming to these filters, there are two different types of filters are there. That is absorption and interference filters. But by using these filters, there is a more band pass when we are using these filters, absorption or interference filters. So first, coming to absorption filters, in case of absorption filters, we can get plus or minus 30 nanometers band pass. That means if we select 300 nanometers as wavelength, but when we are using these absorption filters, we will get either 270 nanometers or 330 nanometers. That is less or more 30 nanometers wavelength difference is there when using these absorption filters. And in case of interference filters, we will get 10 to 15 nanometers band pass. That means if we select 500 nanometers, the obtained radiation range is from 490 to or 510 nanometers. That is either we will get either 490 nanometers or 510 nanometers. 490 to 510 nanometers. That variation is 10 to 15 nanometers in case of interference filters and plus or minus 30 nanometers in case of absorption filters. So to overcome these band pass problems, we can refer monochromators apart from filters to get accurate results. So coming to monochromators, when compared to filters, the band pass is low. That's why it is used as widely in spectroscopy. Monochromators consist of a entrance slit to accommodate the source radiation. That means to get narrow source. So for getting narrow source in these monochromators, we will see the entrance slit like this. This is a slit. In this slit, we will get narrow light source. It has collimating mirror to get the light parallel. So that light should be parallel. For that purpose, we are using collimating mirror in this monochromators, and it comprises grating or prism to disperse the radiation. So for dispersing the radiation, these monochromators contains gratings or prisms, and comprises another focusing mirror to reform the images of entrance slit and exit slit to select the desired wavelength to fall on sample cells. So it comprises of a mirror to reform the images of entrance slit and exit slit to select the desired wavelength. So here we are taking two slits, that is entrance slit to accommodate the source radiation, that means to get narrow source, and exit slit. Aim of or use of exit slit is to select the desired wavelength, and then that is fall to on sample cell. There are two different types of monochromators, such as prism type monochromators and grating type monochromators. So first, coming to prism type monochromators, these prism type monochromators are also two types, that is reflective type and second one is refractive type. In both of these prism monochromators, the light from the source enters from the entrance slit as narrow source and falls on the collimating mirror, and the parallel radiation from the collimating mirror falls on the prism and light can be dispersed from it and finally falls on the exit slit. From the exit slit, the desired wavelength can be selected and falls on the sample cell. So here, this is the schematic diagram of the instrument. Simple colorimeter, that is, this is light source, and these from here to here, this is monochromators. So monochromators, you have an entrance slit for getting narrow source, and a collimator for getting parallel light, and it it is having a prism type or grating type monochromators for dispersion of the light, and finally it pass on the exit slit to get the desired wavelength. From this exit slit, it falls on the sample cell. From sample cells, it goes to the detectors. And in refraction prisms, refraction of the light will take place rather than the reflection. In both, the required radiation on exit slit can be selected by rotating the prism or by keeping the prism stationary and moving the exit slit. Prism have a non-linear dispersion, and it is difficult to focus on desired wavelength through the exit slit. There is an inversion relationship between wavelength and dispersion. Shorter wavelength have greater speed. Second one is grating type monochromators. These grating type monochromators are again divided into two types, that is diffraction grating and transmission grating. So these are the most efficient one in converting a polychromatic light to monochromatic light. So once again I am saying what is the purpose of these monochromators and filters are, we for conversion of heterochromatic light to monochromatic light, because we need only monochromatic light. So for converting that polychromatic light to monochromatic light, we can use these filters and monochromators. So by using these grating type monochromators, the conversion of polychromatic light to a monochromatic light is more efficient, because the band pass is only 0.1 nanometers. So we can get accurate results by using these grating monochromators. That's why it is used in spectrophotometers. That is most sophisticated instruments, that is spectrophotometers. So diffraction gratings. Some brief introduction about diffraction gratings are, these are rulings made on glass, quartz, and alkyl halides, depending upon the instruments like UV visible area spectrophotometers. So these diffraction grating monochromators are made up of glass, either glass or quartz or alkyl halides. So most commonly these are used in sophisticated instruments. In that instruments, it is made up of quartz, because there is no interaction of materials with that quartz. That's why it is most commonly referred in these diffraction gratings. To make the surface reflective, a deposit of aluminum is made on the surface, and the band pass is less or minus 0.1 nanometers. That's why these are mostly used. And second one is transmission gratings. These are similar to diffraction gratings. In these, refraction takes place instead of reflection. These are used in the instruments by either moving the grating and fixing the slit, or moving the slit and keeping the grating constant. So these transmission gratings are similar to that of diffraction gratings. Here only the variation between these two are, in grating monochromators, the radiation is gets reflected. That reflected radiation can be detected. Here, instead of reflection, refraction will take place. Only this is the difference between this grating and gratings, that is diffraction gratings and transmission gratings. In case of prism also, in that name itself, that is mentioned, that is refractive prisms and reflective prisms. There also only, there is only one difference, that is, in reflective type of prisms, reflection is the principle involved, and in case of refraction, this reflection is replaced by refraction. That is the difference between reflective and refraction prism types. This is about filters and monochrome.